Hi, welcome to Easy Math. My name is Zishan, and today we're going to look into the topic 1.1, solving quadratic equations by completing the square method. And this particular chapter is going to be there in your end of term exams. So in completing the square method, there are a few things that one has to learn. I'll tell you the types of quadratics you may get. First of all, you should know that the general expression of a quadratic is supposed to be ax squared plus bx plus c. The kinds of quadratic you may get for completing the square method are when a is a 1, a is not a 1. Of course, there are going to be numbers greater than 1 in here. That's a better thing to say here. A is greater than 1. And when a is lesser than 0, that's also one kind of a quadratic you may get. For quadratics where a is equal to 1, I'll give you an example. Let's take x squared plus 3x, or rather, let's take a x squared minus 3x plus a 5. And how do we complete the square for this one? So let's see. You go write the quadratic as it is, but in here, you're going to add two terms by yourself. Those two terms are going to be, look at that 3. You're going to add a 3 divided by 2 square minus a 3 divided by 2 square by yourself. And of course, the rest of it stays like it was. There's a 5 there. You'll see a 5 there. Now, these two terms were added by you. What happens next is you reduce these 3 to a square. They're going to be x. That's the first term. Because there's a negative in there, you're going to add a negative here. There's a 3 by 2 in here. You're going to write a 3 by 2 and then close the brackets, square. Well, these three terms would reduce to this perfect square. And of course, there's a 9 by 4 plus a 5. From there on, you'd go x minus 3 by 2 square minus, well, this would turn into minus 9 by 4 comes out to be x minus 3 by 2 whole square minus plus 11 by 4. That's your square form completed. And solving this quadratic, after you have completed the square of it, is something that we'll learn shortly. For example, but we just saw an example where a was a 1. But the coefficient of x squared was a 1. Now we go look at an example where a is greater than 1. So we'd go take up a 3x square minus a 7x plus a 9 maybe. And let's see how we can do that. Well, there's only one added step in this quadratic where you're completing the square method. Take a 3 out common from all the terms. See, x square minus a 7x by 3. If you take a 3 out, there's going to be a 3 in here in the denominator plus a 9 by 3. Now, what you see is that this 9 can be reduced by that 3. You'll get a 3 by 1. I would want to reduce them to a 3 by 1. If you don't, it's not that big of a problem. What you do next is look at the coefficient of x now. It's a 7 over 3. Divide that by a 2. 7 over 3 divided by a 2. Well, that's going to be 7 over 3 divided by a 2. 7 over 3 multiplied by a 1 by 2. That becomes a 7 over 6. Well, just like you did a 3 divided by 2 square minus a 3 divided by 2 square. Here, you're going to do half of 7 by 3, which is the 7 by 6. I just showed it to you. 3 in brackets. 3 in brackets. X square minus 7x by 3 plus a 7 by 6 square minus a 7 by 6 square. Let's use a different color for this one. 7 by 6 square minus a 7 by 6 square and plus a 3. A 9 by 3 is a 3. Yes. Now I'm writing these two in a different color so that you remember that these are the terms that you introduced into the quadratic. Eventually, 7 by 6 square minus a 7 by 6 square is actually a 0. So makes no change in the value of the quadratic, but it does bring you a perfect square here. What you do now is you bring in a 3, and these 3 reduced inside a smaller bracket. We'd go x with a minus, and the 7 by 6 should be there, and close the brackets. Well, this, which is a 49 by 36 plus a 3, can be done manually or on the calculator. You go x minus 7 by 6 squared minus, take the LCM of 36. There's a 49, and then there is a 36 into 3. I think that's 108. Remember, this is a minus 49 by 6. A common mistake would be to add these two with a minus out there. Well, that's a mistake. A better way to write it is put up a plus and a minus 49 plus 108 by 36. That's a way. Or you can just do them separately, plus a 3 with a LCM of 36. There's a minus 49, there's a 108, and from there on, you can do it manually. So 108 minus 49 is what you're looking at. Well, it would be a 3 times x minus 7 by 6 square plus 108 minus 49. Well, that would be 59 divided by 36 there. And now you need to bring the 3 inside the large bracket. This 3 comes in, multiplies with the small bracket, x minus 7 by 6 squared, plus that 3 multiplies with the 59 by 36 in there. Well, you're going to get 3 times x minus 7 by 6 square plus 59 by 12. Well, that again is the square form for this quadratic. Okay. So that's basically it. I'll repeat. Take a 3 out common. Introduce the half of 7 by 3 squared minus 7 by 6 squared. Reduce the first 3 terms inside the bracket. These brackets are important, remember. And then reduce the first 3 terms to a square like this. This, keep in mind, is literally a minus 49 plus 108 by 36. Don't go put a minus 49 plus 108 by 36. That would be a wrong thing here. And of course, you need to bring the 3 inside that large bracket. You get this. This is the square form. Okay. Now let's look at the quadratics where a is lesser than 0. So let's do a negative 2x square, negative 5x plus 5. That's the quadratic. So let's see what you're going to get there. Okay. So we are given a negative 2x square, negative 5x plus a 5. Okay. Here, like you did it in the previous one, take a negative 2 out. When you take a negative 2 out, you're going to get an x square. And you're going to get a plus 5 by 2x in there. Remember, what you write here, when multiplied by a negative 2, should give you a negative 5. That's how you take a negative 2 out. Make sure this negative 2 you've taken out should multiply with the term you're introducing here to give you a negative 5. Minus 2 into 5 by 2, minus 2 into 5 by 2 is a minus 5. And that is why what we have written there is correct. Okay. Now, let's talk about the rest of it. Yeah, there it is. With that's actually a minus 5 by 2. Again, reason, this negative 2 multiplies with that negative 5 by 2, gives you a positive 5. That is why it needs to be a negative 5 by 2 inside. What do you do next? Well, I look at the coefficient of x. It's a 5 by 2. I'm going to introduce again by myself two terms. One of them is going to be a 5 by 4 square, and the other one is a negative 5 by 4 square, and of course, a minus 5 by 2. What happens now is that these three are going to reduce to a perfect square, x plus 5 by 4 square. That is a 25 by 16. That's a minus 5 by 2. Now, remember, I introduced a 5 by 4 because it is the half of 5 by 2, 5 by 4. Okay. And then I go deal with the two minus 25 by 16 and minus 5 by 2 here. It's going to be a minus 25 by 16 minus a 40 by 16. That's what a 5 by 2 is. And that is going to be a negative 2x plus 5 by 4 square minus 65 by 16. And then you can bring the negative 2 inside, and it's going to be plus 65 by 8. Why did it become a 65 by 8? Only because this negative 2 multiplies with the negative 65 by 16. The negatives turn into positive. The 2 and the 16 cancel out. You get a positive 65 by 8. Well, that again is the square form. Well, that were the examples. All three kinds of quadratics that you may get there. So what I do is I keep them here in the notes for you to look at. I'll also upload the notes beside this video on the website. IGCSE Math is the website's address. Next, remember this one is about solving quadratic equations. What we have done is we've only obtained the square form of it. Solving this quadratic is another thing. Let's take one of these. Let's take x minus 3 by 2 square plus 11 by 4. As an example, we're trying to solve this now. So you go x minus 3 by 2 square plus 11 by 4. That is the quadratic now. We have completed the square of it. You want to solve it, equate to a 0. Next, you go x minus 3 by 2 whole square equals minus 11 by 4. Well, unfortunately, square of a number can't be a negative. So there are no solutions for this quadratic. Because x minus 3 by 2 squared, there's a square here, can't be a negative number. That is why there are no solutions to this quadratic. But if there was a positive number, I could have gone ahead. Let's look at another example where we can actually do it. So there was our first quadratics. And now we can actually go look at some other one. Do we have? Oh, yeah, I think we can do this one. Okay. So we're going to take this negative 2 x plus 5 by 4. Let's delete this. Negative 2 x plus 5 by 4 square plus a 65 by 8. So negative 2 x plus 5 by 4 square plus a 65 by 8. Now for solving this, we're going to have to equate it to a 0. What happens next? You have a negative 65 by 8. Next, you divide both sides by a negative 2. Well, this by a negative 2 and that by a negative 2. These two are going to turn into a positive 1. But this is going to turn into negative 1 by 2 when division turns into multiplication. The negatives would cancel out, and this would become x plus 5 by 4 square equals 65 by 16. And now x plus 5 by 4 is going to be, you need to get rid of that square now, becomes a square root of 65 by 16 with a plus and a minus there. This is a x plus 5 by 4 equals plus and a minus root over 65 divided by root over 16. Root over 16 is just a 4. So we are looking at root over 65 divided by 4. Now we're going to get rid of that plus 5 by 4. Well, you're going to get a root 65 by 4 minus a 5 by 4 and x equals to negative root of 65 by 4 plus minus a 5 by 4. Every time you get rid of that negative plus 5 by 4, bring it to the other side, it's going to turn into a negative 5 by 4. But a plus 65 by 4 will give you one solution and a negative root 65 by 4 will give you another solution. There are going to be two x values here. And if they're asking for the decimal values, you can actually do it on the calculator or you can leave it here because root 65 manually may not be possible for you to find out right now. So that was solving a quadratic by using the square method, completing the square method. And those were the three examples you're going to get. We're going to get into topic 1.2 next. And for now, this is all there is. I'll see you. Bye-bye.